Right, so finishing up on our revision worksheet, I'm quickly going to go through this with you. So we have done question 1 in class in the live lesson. There's the memo for that. I will be also posting a PDF format for that. So once again, I know that sine in 360 minus is going to be a negative. Just draw a line. So 360 minus will give me negative sine. Then I have cos. Now the moment I have a 90 minus, I know that that needs to change to a sine. Everything in 90 minus, because 90 minus is there, will change to a positive. And then when I have the next one, I see it is a negative angle. I'm going to add 360 to it. So that is actually sine, and then that is 180 plus x. Right, so at the bottom here, 180 plus means that I have it in here, and that is in tan. That becomes a negative cos x. Tan to the negative is a negative tan, and then I have a sine x there. Right, so I can sort out that last one here, because I know in 180 plus I will have a negative. So just basically copying everything down to that last one, that's minus sine x. And at the bottom I have minus cos x, minus tan x, and sine x again. So, like I said, I like to sort out the signs first. So a minus and a minus is a plus at the top, and a minus is a plus at the bottom. So that takes care of the signs. All right, I can see that I can cancel out the sine x and the sine x at the bottom. So I have a problem because there is a tan x there. And that tan x I can take away. Right, so I'm going to make my life a little bit simpler, and I'm going to say sine x and sine x is sine squared x. I am going to divide, and instead of using a fraction, I'm going to use a divide by sine, because cos x, tan x I can rewrite as sine x over cos x. Okay, so within that I notice I can cancel out the cos x, which means I have sine squared x over sine x, and my answer is then sine x. Okay, a lot of thinking going into that question, and if you don't know your theory, you won't know what to spot. Right, number B. So they throw in the square root to test whether you can stay calm or not. Right, I'm going to first leave the 1 plus cos 40, the first bracket, as it is. And then I notice that sine 230 I could have worked out by saying 80 plus 50. Okay, so I have 1 plus cos of 40. That means I have 1. And in 180 plus, I know sine is negative sine of 50. Looking at these two, I notice that I have co-functions, because I can choose any one. I'm going to choose the first one. I can rewrite cos 40 to say that that's 90 minus 50. Right, so I have 90 minus, I know everything is positive, but cos needs to change to sine. And looking at this, I have a binomial times a binomial, which means that I have difference between squares. So I am going to end up with what? 1, yeah, I'm waiting, minus sine squared 50. You agree with me? 1 times 1. Yes, no, maybe, yes. And that over there, well, with the square, because 1 times 1, there we go. Difference between squares, a plus times a minus, sine times sine is sine squared. Okay, and that is my answer. Right, moving on to question number 3. The prove is the key word, which means create a brick wall, because I have a left-hand side and a right-hand side. Okay, so focusing on my left-hand side, I can identify that this 1 minus sine squared theta is actually an identity, because I can replace it with cos squared theta. Instead of writing 1 plus tan squared, I can write 1 plus sine squared theta and cos squared theta. Okay, I have a normal distribution happening here, cos squared theta times by 1 plus, and that's going to be cos squared theta times, I'm going to write it out for you, times sine squared theta over cos squared theta. So I notice that those two will be cancelling out. So I have left cos squared theta plus sine squared theta. That is an identity. That's equal to 1. Therefore, my left-hand side is equal to my right-hand side. Okay. Now I look at the next one. Real instruction is still proof. So I have a left-hand side and a right-hand side. The right-hand side is not offering me much, so I am going to look at the left-hand side. Now looking at the left-hand side, I cannot do anything to sine theta plus 1, but I do have the ability to rewrite cos squared theta as 1 minus sine squared theta. Okay. That means I can simplify the denominator in my second fraction, because that is difference between squares. So I have 1 plus sine theta, 1 minus sine theta. Right, once again, we have algebra, we have fractions, we have an expression, which means we need an LCD, but that LCD needs to repeat in every single step. Now looking at sine theta plus 1 and 1 plus sine theta, it is exactly the same thing. Okay, and I need 1 minus sine theta as the second part. So at the top, I am going to multiply with 1 minus sine theta, and I'm just going to have negative 2 right there. Okay, so distributing the 1, I have 1 minus sine theta minus 2, and at the bottom I have sine theta plus 1, and I have 1 minus sine theta. Okay, so 1 minus 2, so I have negative sine theta minus 1 over sine theta plus 1, 1 minus sine theta. Right, I can take out a common factor there. Okay, so I have taken out a negative, so I have sine theta plus 1 inside, and at the bottom I have sine theta plus 1, 1 minus sine theta. Okay, so I can cancel out those two, reminding myself of what I need. I need 1 over sine theta minus 1. And at this stage, 1 and sine theta is the wrong way around. Because it's a two-term bracket with a negative inside, I have the ability to go and swap them around, but what must happen? There must be a negative that goes out, and a minus divided gives me a plus, and that's how I get my left-hand side equal to my right-hand side. Okay, that was your difficult question, basically. Right, so if I look at the next question, it moves into general solutions. And the first one they give you there has to do with cofunctions. So if I divide both sides by cos, I get tan theta is equal to 2. What do I know about tan and general solutions? The inverse of tan plus k times 180, and k is part of integers, and my reference angle, if they don't tell you, always use 2 decimal places. Remember, I snipped it from a question paper, so the instructions would have been at the front. Now find values for theta. So that means go substitute k. So if I substitute k with -1, I did it to save some time. Theta works out to be minus 116,57. If I substitute k with 0, theta works out to be 63,43. I tested what happens if I substitute k with -2 or k with 1, and that falls out of that range. So theta is minus 116,57 or 63,43 degrees. Okay. Determine the general solution. If I have 3 sine squared beta equals 14 cos beta minus 2, this is a trinomial. All right, what do I notice? I have 2 ratios in there. I can only solve an equation if I have one type of ratio. And the only one that I can rewrite is sine squared beta. I can use my square identity to isolate sine squared beta, and I can replace it with 1 minus cos squared beta equals to 14 cos beta minus 2. When I distribute, I get 3 minus 3 cos squared beta equals 14 cos beta minus 2. This is a quadratic equation, so I'm going to move everything to one side so that I create my 0. Okay, and that's going to be -5. Now, once again, at this stage, if you do struggle, you can, on a piece of paper, go and work out what is 3x squared plus 14x minus 5 and factorize that. So I'm going to have 3 cos beta in one bracket and 1 cos beta in my second bracket. Keeping in mind I need plus 14, so 3 times 5 is 15 minus 1. So it's going to be 3 cos beta minus 1 and cos beta plus 5. Okay, so I'm going to have 3 cos beta equals to 1, or I'm going to have cos beta equals to -5. Because my cos graph doesn't support the -5, I am going to write non-applicable there. Okay, so I can say cos beta is equal to 1/3, which means beta, because its general solutions, is plus or minus cos of a third plus k times 360, and k is part of integers. And using my calculator, I am going to get 70,53 plus k times 360 as my answer. Okay, plus or minus. That's it. Have a nice day.